I'm just going to start by asking everyone to introduce themselves briefly, say a few words about your company, what you do there, and then we'll get into the panel discussion. I will be asking questions of the panelists, and we will have a few minutes at the end for audience questions as well. So can we start on this side with Scott?
Great. Hi, everyone. My name is Scott Casper. I'm Director of Sales and Business Development for GOWIN Semiconductor, responsible for the Americas region, North and South America, developing sales as well as business development activity.
Hi, I'm Larry Lapides. I'm Vice President of Sales for Imperas. I've got worldwide responsibility for that. I'd also like to point out that I'm a Cal grad, and given that this is RISC-V is a Berkeley invention, I just wanted to mention that, and also just remind everyone that it's Big Game Week, and this is a Berkeley technology, not the other guys.
Go Bears. Go Bears.
All right, Charlie, I think we know you already, but go ahead.
Yeah. Hi, everybody. I'm Charlie Su. I'm CTO and Senior Vice President of Analyst Technology. I'm running product development, R&D, and also technical marketing.
No, yes, yeah. My name is Cesare Garlati. Go Bears. I'm a Cal graduate myself, along with my fellow Larry. I'm the founder of X5 Security. I think you will find X5 Security interesting because this is the incarnation of the old concept around RISC-V. We are two guys in a garage startup, and we were able, and we got funded, and we have a commercial product, and we were able to do all of this in few months just because of the openness of RISC-V.
Great, thanks, guys. I wanted to start with Charlie. Charlie, you talked about some of the RISC-V CPUs from Andes, and which are similar to a lot of the other RISC-V CPUs, I think, that are out there in terms of performance. So what kind of applications is RISC-V targeting right now? Where would you commonly see RISC-V being used?
Yeah, I would say just like RISC-V's slogan, RISC-V is for all computing devices. But other than the main processor for mobile phone and main processor for the desktop server, I think other than that, everywhere is possible.
So, can you give us some examples maybe of what your customers are doing and kind of specific designs or applications are they targeting?
Yeah, so right now, Analyst has over 10 customers licensed RISC-V. Starting from the storage, networking, and also FPGA customer, and for them more entry level like MCU, fingerprint, and the rest of them are for AI. So a lot of different AI customer use it different way. So I would say over the place, and a lot of interest right now is all kind of more diversified. So pretty much everyone is interested in RISC-V.
And so there's a lot of open source RISC-V CPUs available. So what are the key advantages that a commercial RISC-V core offers over some of the open source cores?
So we know some customer, like big customer, they have internal development team, and we also know some staff, they like to leverage the free open source code to start with. But we also have several customers, they try the open source code and then eventually they call us and start to do evaluation. Because even though it's free, but it's not really free. You need people to kind of to get it, to make it work, hardware and software, all the different tools. That's actually quite time consuming if you are not kind of the expert of this. And even for large customer, large company, they still think about whether they need to build internal team or they just kind of come to the IP vendor with credibility, because building internal team may not be a way of saving money.
Okay, Cesare, you've been working with some of the RISC-V cores. Do you have a comment on how the commercial cores and the open source cores compare?
That's a slippery slope. I do have an opinion. Yes, we are one of the first companies that actually went through the full cycle of developing at a very low level, just hitting the bare metal security application, in our case, which is a trust execution environment. And we experience, as of now, 3 major vendors. I want to be fair with other companies in the space. I have no problem sharing my experience, which is the Analyst cores look like the most professional ones. To be a little bit more, and this is not free support for the host. It's an honest impression. So I feel like when I work with their stuff, it's driven by market requirements. The features that are there, very little ones and more important ones, are definitely there for a reason. I don't see this yet with other commercial cores, which seems to be driven more by the desire to do something newer or something that goes faster than the big names out there, or just cool, right? And so I think it's great for a tribe because it's diversity of the ecosystem. And so, as someone showed in the slides before, there is a little bit of everything for everyone, and that's good. This is not constrained by one single vendor. The other thing that I noticed is that and this has a lot of extensions at all the levels, from the hardware instruction set to the tools and libraries. And this is great, but it's a little bit difficult then to really take advantage of this kind of advanced features when you move in a more kind of, then there's more variety in terms of systems out there. And I would like to go back eventually later on the concept of whether an ISA, which is really a contract in between the microarchitecture and the software underneath it, can really fulfill the overall platform need.
Yeah, you'll get there. So can you, you mentioned that there's some specific features that are in the Andy's course. Can you just give us maybe an example or two of things that are missing from other?
Sure, we get really into the technical things.
Yeah.
That's fine. But for people who actually work directly with assembly and instructions, the standard RISC-V ISA, it's really tough in the sense that there are very few instructions, okay? And to do very simple things such as a load and a check and a jump, it takes 4, 5, 6, 7 instructions, which typically go from 1 or 2 cycles each. While with Analyst, there are some accelerated ways, I'm trying to be kind of generic here, where you can do this in a very few instructions. Now, to do with less instruction, it's a big deal for cache, okay? Because obviously the more stuff you bring into the cache, and then the more likely you are to run in a miss. That's one of the examples. The way the stack is managed, which is a safe way of managing the stack. And as I said, we need to go very low level, but I think that's the concept, right? I have the feeling I'm working with something that's been designed with market requirements in mind, rather than something that needs to hit the market to figure out what's missing. Interrupts is another big one. The standard, that's what is called PLIC, a platform level interrupt controller. This is the standard described terminology. It's really designed with the idea of really a protocol of handshaking on top of cores so that they can interact an incoming interrupt request and figure out what core will manage it, and it says, I claim it, that's the terminology. Then you process the interrupt, and then afterward you say, I'm done with interrupt, it's been completed. This is a ton of cycles. It would never fit an MCU kind of real-time application where in 2-3 cycles you want to start hitting your handler, right? So the Analyst implementation that I've seen, it's way better. It's more kind of, we're getting a little bit more in the context of how many specifications are for how many interrupts, right? So there's something else called the core local interrupt or sealant. But to be brief here, I don't want to take all the time, right? So working with Analyst, I had a feeling that someone already was there, knew that you need actually to process interrupt in probably a more practical and in a faster way, and that's available.
Great.
I have many more of these examples, but with the rest of the panel.
Great, thank you. Larry or Scott, do you have any insights into the open source cores versus commercial cores?
So from a company perspective, when we were out looking for cores, we actually did look at both some of the databases that did have open source cores in them, thinking that may be a way to start. But what we found out was that the development time, the resources are quite a bit to actually even take what is out there, the ISA as it is, and develop something out of it. Being an FPGA company, we don't have those resources, so we opted for looking at commercial cores. Like was mentioned before, there are quite a few people out there. We looked at top three, Andy's being one of those, and you can imagine who the other two are. And we decided to use the Andy's core based on the maturity that they had in their tool set, the feature sets that they were putting into the device, and also the fact that they understood the IP microprocessor market extremely well, having been around for a while. So we took all these factors together and we decided to go with that core. We could have maybe looked at, continued down the open source path, looking at something off GitHub or something. But in the end, I think we still would be without a solution today.
So we have a different perspective on this. At Imperas, we build simulators, software simulators, or virtual platforms, and therefore we're building models of the processors. And so we take a look at all the processors that are being built by the IP vendors, whether they're the supported ones, the commercial ones like from Andy's, or the open source ones. And in addition to that, Imperas has been very active on the compliance working group in the RISC-V Foundation. And so as we look at these cores and look at the vendors, we're actually doing compliance testing. And to date, Andy's is the core that has been the most robust. And the open source ones are nice, they're free, they're easy to get and easy to use. But they're not commercially supported, and that's a disadvantage to serious users.
Mm-hmm. So Larry, when you say robust, what do you mean by that?
In working with the different processor IP vendors or the universities doing the open source implementations, and working with them to test our models of their cores, and to in parallel work with the test suite that's being developed by the compliance working group. We get a feel for the methodology of these companies. We get a feel also, not a feel, we have direct metrics on the on their coverage in their verification of their RTL. And Andy's clearly has the most mature, most robust methodology, and from that perspective, the most solid cores out there.
Mm-hmm. Great. So Larry, I have a similar question about some of the tools. There's a lot of open source tools out there for developing on RISC-V. So is there an advantage to working with commercially supported tools vendors?
Well, of course there is, Linley.
That's what we call a softball question.
Yeah, it's a good one. But actually, it's so there is a parallel between the open source cores or commercially supported cores and open source tools and commercially supported tools. And we do see that there's a place for the open source tools, mostly right now, just as with other processor architectures, the place for the open source tools is in the tool chains, the compilers, debuggers, and that area. And so RISC-V as a community, and Andy's as an active member of the community, have been key in tool chain development, both for GNU tools and LLVM tools. But outside of that, for simulators, for debuggers, for other tools that are needed to to build your SoC, port software, bring up software. Again, I think for someone that's serious about using RISC-V, commercially supported tools are going to give you an advantage in terms of the usability of the tools and the time to market to bring these things up.
Great. Scott, do you have any input on the tool side? What have you guys been using?
So with respect to tools, we've been pretty open as far as the availability of tools out there and wanting to actually qualify all potential and possible tools that are available. That includes the open source tools like Eclipse and some GNU type tools, as well as some commercially available ones that are able to be used on the device. So from our perspective, to get the ecosystem supported, to get the ecosystem up and coming, we're open to looking at all different types of tools and working with all different kind of partners, including Imperas and Andes and everyone else out there to make this to make RISC-V really happen, because it's going to take a team effort or a village effort, if you will.
Cesare, what kind of tools have you guys been using? And
Yes, so it's completely open source. And in particular, we are using the standard new tool chain, everything included. We actually built it once in a while straight out of GitHub. And as far as we go, it works just fine. In terms of IDE, I personally started using Eclipse many, many years ago, and so I find it very natural environment for me. The proprietary version of many vendors just add plugins here and there, useful plugins, but personally I prefer just to go to the source, and again, I get it directly from their repository, and then I just build whatever is missing there. What I found really useful is a so-called MCU plugin, which I think was developed for ARM in the beginning, although it's open source, obviously, as everything else with Eclipse, which gives a little bit of an edge for C and assembly development for microcontroller, I would say bare metal applications in general. What I found very useful also is OpenOCD. OpenOCD works straight on top of JTAG and with GDB, and what I found really interesting is that it doesn't really matter what kind of core you are hitting on the other side, as long as the JTAG implementation is done rightly. It just shows up as a RISC-V core. And so that's, if you think how many hours it takes just to figure out any proprietary kind of plugs and heads and wires, and just you go there and say it's RISC-V, it works. I think as far as tools, there's as much as we've been exposed to. Obviously, I appreciate all the advantages of working with commercial products, and so to Larry's point, open source is a lot of fun. Well, it's a lot of trouble too, okay? So every time you go on GitHub and download something and build it, might not work at all. I just share some real specific things, right? Using OpenOCD, which is great, if your code is less, it's a specific bug in implementation, but that's what it is. If your code is less, I guess, than 128 bytes, you get all sorts of errors, doesn't work. But no one will think because my code is too small. And why my code is small is because I'm testing some specific functionality, right? It has to be minimal. So it's just as this, it sometimes takes hours, if not a couple of days, just to figure out these things. So open source is great for innovation, and that's what allowed a company such as a startup in a Silicon Valley garage to come to commercial product in a matter of months and get it funded. But sometimes a little bit of frustration. So I think there is, as Larry said very well, there is a place for commercial and there is a place for open source. Mm-hmm.
So Scott,
can I also?
Oh, I'm sorry, Charlie, we missed you there.
Yeah. Andy is pretty big on open source, especially on the software side, and it's probably the only company both working on GCC and LLVM. Our compiler team just compile itself with 10 people, not to talk about the library, assembler, disassembler, and so on. So, and we have our in-house near cycle accuracy simulator, and we also work on the QEMU. But that said, I think the world is bigger than we know. So we are partnering with all kinds of different commercial vendors, like in the simulator side. We are working very closely with Imperas. We have a co-simulation environment to verify each other. And we have our own eyes, OpenOCD and GDB, but we also have good partnership with Lapides and other debug vendor. And compiler side, toward end of the year, I think probably before Summit, we're going to have an announcement with another new third-party compiler vendor. Maybe you can guess who he is. But I think what we think is open source is good, and a lot of people like it, but the world is much bigger. So we want to enable the ecosystem for everyone who want different things.
Great, thanks, Charlie. So Scott, can you tell us about the importance of FPGAs in the RISC-V ecosystem?
So FPGAs are a great platform for the RISC-V core to come out. It's a great platform for the hobbyist or people to start to look at it, to get familiarized with the ISA. Moving forward from there, we're finding actually a lot of uses where people are taking advantage of the new FPGA acceleration or the acceleration capabilities that are being put into FPGAs, such as AI, for instance, AI accelerators, and they're using cores like RISC-V to be able to do some of the housekeeping or some of the slower applications on it. So, right now we're finding FPGAs are kind of in mode, which is great, great for me. And the RISC-V core actually works really well. Being able to, it's a simple core, it's an easy core to use, and we're finding our customers, as they're looking at it, are able to implement their designs well with it, and then also take advantage of some acceleration needs that they have. So.
And Lily, if I can quickly interject something there. I found a lot of value in the RISC-V world working with FPGAs. And the reason is that we actually are able to come up with a company and have a commercial product in a matter of months. When you saw in the other slides, it takes quarters, if not years, to get silicon. So FPGA is really an enabler for innovation at this point. And in fact, I think of the many boards that I have in my lab, only one has silicon on it. They are all FPGAs, the other one. FPGA is really an enabler for innovation. And in the case of RISC-V, it's essential. Because if company waits for mainstream silicon to be out there, well, that's going to take a while.
Great. And Cesare, I wanted to ask you, since you're the security expert, so I've heard kind of two schools of thought. I mean, one is that because RISC-V is an open source, that you can't put trapdoors in, that it's easy to see, it's very transparent if there's any security problems. But there's also the theory of security through obscurity, right? That if you can't see what's going on, then it's harder to find a security flaw. Right. So do you feel like RISC-V is more secure or less secure than traditional IC?
That's a great question. And so we have a presentation of 45 minutes, I guess, in the afternoon to go through the details. So here is the short version of it. Security through obscurity never existed. It's a myth. The company that branded this kind of concept is called Microsoft. And so Microsoft is responsible for the development of a multi-billion-dollar industry trying to fix the things that broke, okay? So I'm a member of the security community. I'm involved with many open source and non-profit, technology non-profits, from the Cloud Security Alliance to Purple Foundation. There's no single security expert that would believe in security through obscurity. It just doesn't exist. Microsoft is closed source, and you get patches that fixes every Tuesday. PDF is closed source, and it's the same story. Flash, who uses Flash still? Okay, be a shame if you do it, right? So the closed source never worked. Now let's get to the RISC-V. Open source is not guaranteed for security, okay? But it allows two very important things. The first one is that you can have anyone around the world looking at what you're doing and trying to break it. if something is not rock solid, it will get broken in a matter of hours. So Apple announced, just check my tweets if you want to get all the details. Check me on Twitter. Apple announced something they developed with ARM, and that was announced just a month or so ago, where they had combined teams working for months about something about protecting pointers. One guy, young guy, in 1 week completely broke it, okay? So that's the idea of opening up. So it adds security indirectly because you are definitely immediately exposed to attack. The other aspect of security for open source, which is true of Linux, and it can be immediately fixed. If I find something wrong, I fix it. If you find something wrong in Windows, good luck with that, right? So now let's get to the specific of RISC-V just for 1 second, because that's an excellent question. People in the room should be aware with some of the latest and really concerning security issues that happen to leading platforms. Spectrum, Meltdown, these are some of their names, but the whole concept of out of order, it's really messy, okay? It gives you a lot of performance, but it's really messy in terms of what remains in the state of the processing, whatever it is, the cache, the pipeline, and so forth. And so there's no fix that you can get from an ISA there. So I'm sorry, you are not going to fix this kind of things because it's a microarchitectural issue. And we have the experts in the room here, so I'm very happy eventually to be contradicted here, but you cannot specify in an ISA, which is a contract in between the software and the hardware, how you're going to manage the pipeline, clean up caches, do whatever you do. There's something that has been added to the standard ISA for RISC-V, which is about fencing. And if you ask me as an expert, it's a start, it's very minimal, but that's the right thing to do, which is to add to that contract some of the aspects that are really intrinsic to the microarchitecture, so that a software layer on top of it can perhaps clean up caches when it switches the context in between kernel, in Linux world, kernel and user mode. That's just an example. The other thing that I really like, and I'll be quick here, okay, that I like about RISC-V is that it's a clean slate approach. So all the legacy stuff, I mean, if you check the news, there are some researchers that figure out there are some hidden microcontrollers into the x86 architecture that no one knows why they're there. Okay, these things are not happening in RISC-V because simply it's clean slate, it's new, there's no legacy, there's no excuse for having anything there. The other thing that I really like, and someone mentioned before, is the clear division between protected or privileged modes and anything else. These are two different documents, completely separated, and so there's no messing up with them. And the physical memory protection also, so-called PMP and PMA, physical memory access. These are really great features to develop the kind of security into the hardware itself, like Dockers at the chip level, right? That is absolutely a requirement for security in 2018, in addition to anything that you put on top of it. And that's what really enables trust execution environments. And so perhaps more in the afternoon, people who join my presentation.
All right, more this afternoon.
Yeah,
Larry,
my Berkeley education was a bit different from Cesare's. I actually learned the meaning of the word brief. So a couple of other comments on security, and basically related to the RISC-V architecture. You have the ability to add custom instructions, and so one of the things that we've been seeing is some companies doing some innovative things in the way of security, either through encryption or actually extending the ISA to add innovations to be able to, within the ISA, defeat side channel attacks. And so in this way, I think RISC-V and the open ISA is actually quite beneficial from a security perspective.
great. So we've heard a lot this morning about the flexibility of RISC-V, adding custom instructions, but it brings up the specter of fragmentation. So how is the software going to evolve for RISC-V as all these companies are moving in different directions? I don't know, Charlie, you want to start with that? Andy's has created these extensions for RISC-V and you get better performance, but then doesn't that break compatibility with other processors?
It won't. So what we do is that we support RISC-V as a subset. So everything which available outside, I mean, all the Andes, all the development tool, the IDE, and so on, compiler, they can use together on the SoC with Andes processor because we support everything RISC-V has. I mean, in a subset, for example, if you're integer cores, definitely you don't have floating point, but for integer, all the different integer IMAC will support that. So, and actually this is not just a problem of instruction extension. Think about this. Right now, RISC-V has so many different how do I say, the modular extension, right? So you started with I, 32 register, or E, 16 register, and you have a lot of other stuff, IMAC, FD, and so on. So think about the many different combinations. So, so even though they are RISC-V compatible, but if there is no good way to manage this, and you have chip out there, and you get a tool from anyone, and if there's no way to recognize what you have, you're going to generate, for example, say if you don't have M, for example, you don't have multiply divide, and you take a tool which doesn't know that you don't have that instruction, and generate M for you, and you're going to get exception. So even though inside RISC-V would be like that, but this is not just unique to RISC-V. Think about ARM, right? So they transition from there's a popular V4, V5, and then V6, V7 to VA. And so there's so many different ARM chip out there, different processors. So how does a tool and also application environment manage that? So there are ways to do that. So you have to create the so-called application environment. And for us, the way to do it, if you all use Andes toolchain, there's no problem. But if you want, for example, you like your customer to leverage the open source environment. So what you can do is in your runtime, you provide to your customer, which can build with Andes tool. And so you can fully utilize Andes feature. But when you go out, you ship your SDK with your library, but you want to leverage the other part, which is the rich development environment out there. Then you can use standard still running on top of the platform based on Andes core with a runtime which is fully utilized Andes feature. So I think it's a well managed the environment. You won't have a problem. I would use example for example. Android environment. So Google lay out the foundation, so the compatibility environment, so that all the different phone vendor they can run app, but it still allow them to do customization. So when you get a phone, initially they look different. So there's a good way to manage this kind of so-called extension to create innovation, but still keep the whole ecosystem together.
Go ahead.
So there's a real balance that needs to occur here in the RISC-V community between compliance and fragmentation. Too much of people sticking to the basic specification and really you're just back at what an ARM processor is. Too much fragmentation, too many different instructions, too many different extensions, and the problem is that the ecosystem can't keep up with that, and the ecosystem, the tools companies, the software companies don't have the leverage to make money actually off of RISC-V if there's too much fragmentation. So I think what Charlie said about Andes and a well-managed ability to add custom instructions is actually key to this. It's all in how you do it. And again, that I think goes back to the open source versus commercial company question. And open source, you can do whatever you want, but you're out there on your own. If you have a managed environment, then it's much easier to go and do the customization that you need to do.
Okay, we have time for some audience questions. Question here?
Yeah, I have a question.
Oh, we're going to get you a mic, make it a little easier.
Thank you. I have a question for the whole panel. So please name one biggest challenge with RISC-V that you faced before or after.
Okay.
Yes. So if I understood right, name one challenge that we have.
One big challenge for
One
RISC-V.
big challenge that we've had so far on RISC-V. For us, in developing with the Andes core and just in general in RISC-V, it was the initial ports of getting the core into our FPGA. To establish and to really optimize on the synthesis of the core and then actually the place and route. Once we were able to understand the aspects of what is the core and how we can actually customize it, which is great about the core is depending on what the application was, we were able to take out certain aspects or keep certain aspects. Then we were able to pretty quickly show customers over a wide range of applications what they could actually do with the core. So.
As a tool provider and looking towards the RISC-V standard, I think our biggest challenge, our biggest frustration has been the rate of progress in the working groups of the RISC-V Foundation. For the most part, the people in the working groups are, even though they're working for commercial companies, it's not their primary responsibility, and so sometimes specifications have taken longer than they should to converge.
Charlie, you have one?
Yeah, I think the bigger challenge is that because RISC-V has been creating so much attraction, everyone thinks RISC-V is the savior, so RISC-V got to have everything. So we got to catch up all the expectation. For example, right now when in China, pretty much every customer asking for RISC-V. So, and they think RISC-V should have everything. So, for example, the P extension, the SIMD DSP, based on the general purpose register, the efficient one, which ARM has on Cortex-M, they think RISC-V has that. So, fortunately that Andes had this experience, so we kind of moving over from our proprietary instruction with DSP instruction. That is actually quite orthogonal to the baseline instruction, so we move that over here. But so this is just an example. I believe a lot of people, when they say they want RISC-V, they probably don't know precisely what they want, or they probably don't know what RISC-V has. But I think this is a good thing. But we already create enough awareness, so we just need to how do I say, match their expectation and develop product fast. And extension, I think, is a good way, because if everything need to kind of agreed by the committee, and before we go on, then some of the market we cannot serve that quickly. They may lose interest. So I think our approach has been that we'll go ahead to do that, and we, for example, for DSP extension, we make that we donate it to standard, and then we will make sure that later when the standard evolve, we can keep our customer kind of moving ahead by creating the so-called intrinsic function layer, so that our customer don't need to worry about if they take our implementation right now and later you're going to change, because we have the compatibility paths for them.
I think there's a fine line between reaching for the stars and over-promising. So, Cesare, you?
With the blessing of my fellow Berkeley graduate, I have an undergraduate degree from Europe, humanistic, and we learn how to be articulated. And people like go Bears. So here is the thing. I can speak for security, and this is specific to security. The incumbent out there figured out that security cannot be sold in terms of ISA. In fact, they created a brand name which is called PSA, Platform Security Architecture. It takes to go into the details to really understand what I'm saying, but I think that's going to be a challenge, definitely. As far as RISC-V remains an ISA, I don't see how security will become really the best in class, because no one runs one core to do anything. It has to be in the context of a system. And that's, I think, the next level of challenge. That was good.
Good. Sure. Yeah. All right. Another question? Okay.
Hi, I have two questions. I was thinking about numbers. A company like MediaTek, how many RISC-V design wins have happened at MediaTek? Do you have a sense whether 5 projects or 20 projects are now are using RISC-V?
Is that for Charlie or?
I'll ask Linley. You, and you can look at Charlie and see if he goes.
Yeah, it's pretty hard to say at this point. I mean, certainly nothing's come out the back end. The design wins are internal. I mean, so MediaTek has been using Andes for a long time. And I think, as he pointed out in his slide, in a lot of the Wi-Fi, Bluetooth type controllers. And so I would expect MediaTek would want to roll over those older Andes cores to the newer, RISC-V based cores over time. And, given how many SoCs, MediaTek probably, puts out half a dozen SoCs a year just for smartphones. And I mean, there could easily be, 5, 10, 15 design wins in progress. My guess.
The second question is for each of the panelists, how many current RISC-V engagements do you have? Can you give us kind of a sense of how much activity you're seeing across your customers and prospects?
Okay. And we'll try to do this briefly, so we can start with Cesare this time.
All the existing IP providers in the RISC-V space.
That was brief.
There's a good reason why Shiqing, the MediaTek director, don't sit here, because MediaTek is very secretive about many things. So can I say that? Definitely we have engagement. So right now we have over 12 customers already. When I say customer, I mean they already licensed. And so how many engagement? I would say all the engagement are RISC-V based, even though we have our PAS processor. So everyone like RISC-V.
I'm not sure the number of engagements is relevant from our perspective, but I'll give you another metric. For 2017, Imperas revenue was split about 1/3 ARM-related, 1/3 MIPS-related, 1/3 other. For 2018, our revenue will be about 1/4 ARM, 1/4 MIPS, 1/4 RISC-V, 1/4 other.
From our perspective with FPGAs, engagements is kind of a tough one, where it's more of design interest, I guess, and where we've actually started talking, because we're in the stages of rolling out the Andes RISC-V core. We've had quite a few. I don't want to get into specific numbers, but interestingly enough, and I think as Charlie had mentioned, surprisingly, it's most of it's coming initially from China. There's a really big push right now in China to adopt RISC-V as kind of the standard for processors, and that's where we're seeing most of our interest coming out right now. Earlier, there was the discussion about challenges. Something else I was thinking about was, just as a general challenge, the education of what RISC-V is. Even though we're all here and the RISC-V Foundation is doing a great job as far as getting the word out, I just spent a week on the East Coast last week, and it's funny, from a West Coast, East Coast perspective, I kind of feel like I'm talking about rap, but I'm not. From a West Coast, East Coast perspective, the East Coast is actually a bit less knowledgeable about what is happening with RISC-V is what I've found out. So.
Okay, well, those were very long questions, so I think we're out of time. But we will have time for you to talk with the panelists later today at lunch and break. So hopefully. So let's thank the panelists.